Hi students, welcome back to my channel Evolve Solving Physics. Today we are going to discuss about some equations based on the object moving in a straight line with uniform acceleration. If an object is moving in a straight line with same acceleration. So based on that concept, we are going to discuss some equation. Let us consider an object is at point A. An object is at point A. I'm considering only one object which is at point A. At point A, point A is the initial position of the object and point B is the final position of the object. At initial position, the object is start moving. So at initial position, the velocity of the object is u. That is initial velocity. So here u is the initial velocity of an object at point A. Point A is the initial position. As that object is moving in a straight line. Moving in a straight line means, as it is moving in a straight line means it has some distance. Here straight line represents direction. So it is moving with displacement s. With uniform acceleration, we know that acceleration is denoted by small a. So it is moving with displacement s. How much displacement it is traveling, we don't know. We are finding that equation to solve problems. We are only considering the terms here to find the equations. So s is the displacement traveling by the object with uniform acceleration a. That object reaches the final position, that is B. B is the final position. So the object does not have constant velocity. Here the velocity of the object is changing. Here we have only constant acceleration but different velocity. For suppose if we are traveling in a car, first we slowly, then later on we increase the velocity. Means we are traveling in a car with faster velocity or speed. So as the object is moving in a straight line, it changes its velocity. So at B point, at final position, the velocity of the object, that is final velocity, is v. Final position, so we are considering it as final velocity v. So initial velocity is u and v is the final velocity. Here the object is traveling from A to B. We don't know the time, how much time is taken by the object traveling from A to B. We are considering that as time t. So based on these terms, we are going to write some equations that are first equation is v is equal to u plus at. This is the first kinematic equation when an object is moving in a straight line with uniform acceleration. So this is the first equation. V is the final velocity is equal to initial velocity plus product of acceleration and time t. So v equals to u plus at. We no need to derive this equation. Just remember the equations based on this concept. The first equation is v equals to u plus at and the second equation is s equal to ut plus half at square. These equations is only applicable when an object is moving in a straight line with same acceleration. And third equation is v square minus u square equals to 2as. The derivation of this equation, no need for everyone. Just remember these equations which will be more useful in later class or in solving problems. These equations are very important. So first equation is v equals to u plus at. You have final velocity is equal to initial velocity plus acceleration, product of acceleration and time, v equals to u plus at. Here s is the displacement is equal to u is the initial velocity, t is the time, a is the acceleration, t is the time. So here v square minus u square equals to 2as. V is the final velocity and u is the initial velocity, a is the acceleration and s is the displacement. You have one more equation based on this concept. These are the 4 equations when an object is moving in a straight line with uniform acceleration. Initially the object is with the initial velocity u moving with uniform acceleration a with displacement s, and it reaches a final position with final velocity v. The time taken by the object to travel from initial to final position is t. Just remember that initially means at starting position, the time taken by the object will be 0. When the time taken by the object will be 0? When an object is at rest. When an object is at rest, the time taken by the object will be 0. So here I am taking the time t because here an object is moving from initial position A to B, means there is some time taken by the object. It is traveling from A to B, that is t. So the first equation is v equals to u plus at. In first equation, we are not specifying any displacement in this equation. You can observe that you are specifying only final velocity, initial velocity, uniform acceleration and time. You are not specifying any displacement here in the first equation. Next, second equation. The second equation is the displacement of the object at time t. This is the displacement of the object with time t, that is s equal to ut plus half at square. In this equation you can observe that you have displacement, uniform acceleration, initial velocity and time. There is no term, that is v, in second equation. And for third equation, v square minus u square equals to 2as. In this equation you can observe that you have final velocity, initial velocity, uniform acceleration and displacement. In this equation you don't have any term t. So for next equation, for suppose if an object is traveling nth second, we can't specify any seconds of time. An object is moving, so nth second. So the displacement can be written as Sn. Sn means displacement of the object for nth second is equal to u plus a of means into a of n minus 1 by 2. N means nth second. Nth second means, for suppose if an object is traveling 10th second. 10th second means here 10 will becomes n equals to 10. So you can substitute the 10th second, that is 10 value here in n. At the position of n you can substitute the value 10. This will become the 10th second. So these are the 4 equations which is very important to solve the problems in this whole chapter, that is motion in a straight line. So if you have any doubts based on these equations, so comment me in comment box. So please like, share and subscribe my channel. Thank you.